Right, we're looking at the worksheet visualizing the variables in gas laws. And this worksheet is going to help you understand how the relationships, like what causes the relationships between pressure, volume, and temperature. So your first question is, what causes pressure? Well, pressure is caused by the molecules colliding with the walls of the container. And since these are gas laws, we're specifically talking about gas molecules. So maybe add that in. And we've talked about temperature before, and we know that when we have molecules moving faster, they have more kinetic energy, which means they have a higher temperature. So faster means more kinetic energy, which means high temperature. And in this assignment, when you want a molecule that's at low temperature or moving slow, you're going to draw it with a short arrow. So that's slow. If you want to represent a particle at a faster speed or a higher temperature, you just draw the arrow longer. So when you come down here to pressure and volume, the first question says draw 5 molecules in each box. So just sort of spread them out. Go ahead and do this one over here. And then it says draw arrows representing the kinetic energy of the molecules. Should those arrows be the same length? Well, if the temperature is constant, that's a yes. So I'm just going to sort of draw medium, and we know that gas particles move independently and randomly, so they're going to move in all sorts of directions. Now you want to make the same distance here, even though the box is smaller, and it's harder because you end up running into each other. And that one actually left the box. Which box has the greatest volume? Well, take a look at the size of box 1 and the size of box 2. Obviously box 1 has a greater volume. And then if you think about who's colliding with the walls of the containers more frequently, box 2, since the volume is smaller. And then where it says write a sentence summarizing the relationship, you want to say when you go from box 1 to box 2, the volume decreases, and then what happens to the pressure? We said that the pressure increases in box 2. Alright, so I'm going to do just this first sentence with you, and you can write the rest on your own. When volume decreases, as it did from box 1 to box 2, the pressure increases. Alright, we're going to move on here. Alright, we're going to move on here to pressure and temperature with constant volume. We follow the directions. Step 1 says draw 5 molecules in box 2. And you'll see here that the volume is constant. That's why our boxes are the same size. And step 2 says what variable is constant in this illustration. So we'll go ahead and write volume. And up here it says to use longer arrows to show that we've increased the temperature. So now I'm going to really exaggerate my arrows. These have very high temperature. So the box with the greatest temperature would be the box with the longest arrows. That's box 2. And if you think about pressure and the particles colliding with the walls of the container, which box has greater pressure? Who's colliding with the walls with more force and more frequency? Do you see how it's box 2? Because they're moving so much faster at a higher temperature. So then when you write your sentence, you would want to talk about how the pressure increases from box 1 to box 2 and how that affects the pressure. Right, our last relationship is between temperature and volume at a constant pressure. And the directions say, again, 5 molecules in box 2. Imagine that the pressure in box 2 needs to be the same as box 1. Determine what size arrows are needed to keep box 2 pressure equal to box 1 pressure. Well, if my volume is going way down and I want the pressure to stay the same, does it make sense that these arrows need to be much smaller? Because the only way I can reduce the volume but keep the pressure constant is to give these particles, to make sure they have less kinetic energy. So I'm going to draw them with very short arrows. And of course, pressure is constant. We can read that in the title. And the box with the greatest volume, easy to see, that's box 1. Box with the greatest temperature, just look at the size of your arrows. These are longer, so box 1 has the greatest temperature. And then when you write your sentence, just simply compare how the temperature decreases from box 1 to box 2, or the volume decreases from box 1 to box 2, and what effect that has on the temperature in order to keep the pressure constant. And then finally, there's a few questions at the end here. I just want to talk you through them without giving you the answers. When an increase in one variable causes an increase in another variable, the relationship is called directly proportional. And you're going to look at your pictures and decide which sets of variables are directly proportional. That means when you increased one variable, the other also increased. Or when you decreased one, it caused a decrease in the other. There's one relationship where when you increased one, you saw a decrease in the other. And that relationship is called indirect, or sometimes inversely proportional. One of the sets of variables is inversely proportional, and so that means if one increases, the other goes down. If the first one decreases, the other one goes up. And you can find which one that is and record it here. And that's the end of your assignment.